These days, blockchains are immensely popular. But what is a blockchain? How do they function, what issues do they address, and what applications are there? A blockchain is, as its name suggests, a chain of information containing blocks. This method, which was first proposed in 1991 by a group of researchers, was intended to timestamp digital documents so that no one could modify or backdate them. Similar to a notary. However, it remained mostly unused until Satoshi Nakamoto adapted it in 2009 to produce the virtual money Bitcoin. A distributed ledger that is totally accessible to everyone is called a blockchain. An intriguing feature of them is that it becomes exceedingly challenging to modify data once it has been stored inside a blockchain. So, how does that work? Let's study a block in more detail. The block's hash and the block's prior block's hash are included in each block along with some data. The kind of blockchain determines what information is stored inside a block. For example, the Bitcoin blockchain keeps the sender, receiver, and total number of coins for each transaction here. Furthermore, a block has a hash. A hash can be compared to a fingerprint. Like a fingerprint, it serves as a unique identification of a block and all of its contents. A block's hash is determined once it is produced. The hash will alter if anything inside the block is modified. In other words, hashes are particularly helpful for detecting block modifications. A block is no longer the same block if its fingerprint changes. The hash of the preceding block is the third component in each block. This effectively generates a chain of blocks, and it is this method that contributes to the security of a blockchain. Therefore, altering just one block renders all subsequent blocks useless. However, employing hashes alone won't stop tampering. Modern computers are extremely quick and can compute hundreds of thousands of hashes per second. In order to restore the validity of your blockchain, you may essentially modify a block and recalculate all the hashes of the other blocks. Proof of work is a feature of blockchains that helps to alleviate this. It is a mechanism that inhibits the production of fresh blocks. It takes roughly 10 minutes to calculate the necessary proof of work and add a new block to the chain in the case of Bitcoins. This approach makes it incredibly difficult to manipulate the blocks because doing so necessitates recalculating the proof of work for every subsequent block. Therefore, a blockchain's security stems from its innovative use of hashing and the proof of work algorithm. Blockchains can also secure themselves by being widely distributed, though. Blockchains use a peer-to-peer network, and anyone is welcome to join. This eliminates the need for a central organization to maintain the chain. Anyone who joins this network receives a complete copy of the blockchain. This can be used by the node to confirm that everything is still in working order. Let's now examine what transpires when a new block is created. Everyone on the network receives that fresh block. The block is then checked by each node to make sure it hasn't been tampered with. If everything is in order, each node includes this block in their own personal chain of blocks. Consensus is produced by the network's whole nodes. Regarding which blocks are genuine and which are not, they concur. Other nodes in the network will reject blocks that have been altered. The proof of work for each block must therefore be redone in order to successfully alter a blockchain, and more than 50% of the peer-to-peer network must be taken over. Then everyone will start to accept your modified block. This is nearly impossible. Blockchains are continually developing as well. The establishment of smart contracts is one of the more recent advances. These contracts are simple programs that can be used to automatically exchange money based on particular conditions and are kept on the blockchain. The development of blockchain technology piqued the curiosity of many people. Others soon realized that the technology might be used for other purposes, such as keeping medical information, establishing a digital notary, and even collecting taxes. So you now understand what a blockchain is, how it works on a fundamental level, and what problems it solves. Thank you for taking the time to watch our video. Don't forget to subscribe our channel. Hit the like button and the bell icon so you get the notification of our latest videos. See you soon in our next video.